So in this video we're going to be looking at types of liquid crystals, the characteristics of liquid crystals and the uses of liquid crystals. Okay. So most molecules form liquids when they melt. These liquids have an isotropic structure, and this means they're the same throughout. Okay. If, however, we have anisotropic molecules, that is molecules that are not the same throughout, liquid crystals are formed first before the substance becomes an isotropic liquid. Okay. There are three different liquid phases that we have to become familiar with: the nematic phase, the Smectic A phase, and the Smectic C phase. Okay, let's have a look at the nematic phase first. Okay. So, the nematic phase is an example of a thermotropic liquid crystal, that is, a liquid crystal formed by heating. In the nematic phase, molecules exhibit preferential orientation in a particular direction. Okay, so the long axes all roughly point in the same direction. And this phase requires the molecules to be elongated and rigid. Okay, further heating of this phase causes the formation of a conventional liquid. We can better understand this by drawing it out. Okay, so when I talk about nematic liquid phases, all really it is that these long, rigid liquid molecules, they're all pointing in the same direction. Okay, so they're all pointing in a similar direction. Okay, roughly, like they can be, slightly off axis, but roughly we have all of these liquid, our liquid crystal molecules pointing in the same direction. Now we're going to talk about the Smectic phase. Okay, so there's two Smectic phases. So the Smectic phases occur when all the molecules are also organized into layers. Okay, so this forms at lower temperatures than nematic phases. Okay, so the Smectic A phase is when molecules are layered and orientated on an average normal to the layers. Okay, so let's draw a picture of this to make more sense of it. Okay, so our Smectic A phase actually looks something like this, where we have it organized into layers. So I'll draw some layers. So we have all of them kind of pointing in different directions, but all organized into specific layers. Okay, so as you can see, sorry, this one's a bit rough up here, but as you can see, they're all organized into layers, all pointing in roughly the same direction. Okay, so the next phase is the Smectic C phase, okay? And the Smectic C phase occurs when the molecules are layered and also highly orientated at an angle to the normal of the layer, okay? So they all have the same orientation. This is much more organized than what we see with the Smectic A phase, okay? So let's draw a picture again. Okay, in this case, we have our organized layers. So I'll draw the layers a bit better this time. We also have all of them pointing in the same direction. Okay, so they're slightly different to what we saw in the Smectic A phase, but they were organised in layers. They were kind of all pointing in different directions, roughly all upwards, but in different directions, while in the Smectic C phase, they're all pointing in the same direction as well. Okay, so overall we can say that as a solid is warmed, it's going to go through a sequence of structures. Okay, and the sequence of structures that it will go through is from a solid to the Smectic C phase, to the Smectic A phase, to the nematic phase, and then to the liquid. So as you can see, it goes through, I guess, like how organized the molecule is. So solids are quite organized in terms of their structure. The Smectic C phase, which is more organized than the Smectic A, which is again more organized than the nematic phase. And then we get to liquids, which really are just, as we know, molecules tumbling all over each other. There's no organization to them. Okay? All right. So this brings us on to our next point where we talk about the characteristics of liquid crystals. Okay? So the molecules align, the molecular alignment in liquid crystals gives them certain properties in terms of flow behavior and optical characteristics. Okay? In terms of flow behavior, liquid crystals are viscous, but they do not flow. Okay? They can be poured, for example, they can be poured into a mold and take onto the shape of that mold. Okay? As well as this, they also have particular optical characteristics. Okay? So liquid crystals can actually interact with light of different polarizations. So that is light that has different waves, that has waves of different orientations. So light that has the waves at different orientations to each other. Okay, so that's an important point as well. Okay, so this finally brings us to the uses of liquid crystals. Okay, so we can actually, there are actually some good uses for liquid crystals. Okay, they're actually used for some everyday purposes. Okay, because we talk mainly about the nematic phases, because they're quite fluid. So it's the phase just before we hit liquid, so they're quite fluid compared to Smectic A and Smectic C. Because they're quite fluid, they can reorientate and align themselves quickly in a magnetic or an electric field. When they're unorientated, they are poor transmitters of light, so they don't really let much light through. When they are aligned, they transmit light really well. Okay, so for this reason, nematic phases are used in liquid crystal displays such as calculators. Okay, where depending on which number we want to show, we turn on different magnetic and electrical signals to align the crystals in the nematic phases in a particular way to either allow the transmission of the light or to not allow the transmission of the light. Okay, so that brings us to the end of this lecture, or the end of this video. Thank you.
Cut study time with concise video summaries by top students. Visit spoonfeedme.com to view more free videos in this course and hundreds of others.